Okay, good evening, everyone. Am I audible?
Yes, sir.
So where are others? I have waited for 8 minutes now. Means I was waiting like two more others join so that we can start. Do you know where is Amitesh and Harit? Hmm?
Sir, Amitesh may have a class, if I remember correctly, and he may join a bit late. That's what he told me.
So he can join by like if I can wait for 2-3 more minutes.
No, sir, I don't think he's going to join at like approximately 7 o'clock. So I don't think it's going to be too late.
Okay, by 7 o'clock. And about Harit? Hmm? So if he's very late, so we can start. So we cannot wait for him. Already 10 minutes ago. Okay, so let me start. Okay, is the screen visible?
Yes, sir.
Okay, so in last class, if I remember, I have derived like Kc. Kc I have derived, and there I have told like it is made according to the law of mass action that the product of concentration of products in numerator and the each product concentration raised to power coefficient. So like we are using concentration as a proxy for active mass, we can also use partial pressure. So like some of you have asked me, sir, what is partial pressure? So I have taught you. Like if you are having more than one gases as a mixture in a gaseous mixture, so and if they are non-reactive and they share the volume of container, so they will known as component. And if there is a mixture of gases, they are having more than one component. And if I talk about like partial of any one particular component, so that will be known as partial pressure. So that partial pressure now I'm using as a proxy for active mass. So the reaction I have given again that alpha A gaseous plus beta B gaseous gives you gamma C gaseous plus delta D gaseous. Now, when we will be defining by partial pressure, when we are using partial pressure as a proxy, then it will be known as Kp. Okay, like for concentration it was Kc, partial pressure will be Kp. So therefore the Kp will be defined like this one. Partial pressure of C raised to the power gamma, partial pressure of D raised to the power delta, the product taken in numerator of products. And
Sir, the screen is frozen.
so Kp you are able to see. Kp only I am explaining.
No, sir, it's still on meet.
It is on neat.
The meet window, like it's still on Chrome. Like it hasn't moved to the thing.
Okay, 1 minute. I'm sharing once again. Is it now visible? Hmm?
Yes, sir.
Okay. So once again, I am telling here I am going to define Kp, and Kp will be using partial pressure of different components. So if I am writing equation on the basis of A, B, C, D, so that will be like alpha A plus beta B gives you gamma C plus delta D. So A, B, C, D here are components, and since they are gases, so they will be sharing the container volume, and at the same time, they are already like independent. They are not. They are not actually. For example, you can see like CD is different from AB. So if I'm writing Kp, so it will be like partial pressure of C raised to the power gamma into partial pressure of D raised to the power delta. So this I have written product of partial pressure of products raised to their particular coefficient. and then divided by partial pressure of A raised to the alpha and partial pressure of B raised to the power beta. In denominator, I have written reacted partial pressure product raised to the power their particular coefficient. So in this way, we are writing. Now, if I talk about unit, so partial pressure is actually given in unit as a ATM. Okay, so since it is pressure, so its unit will be like ATM. Now you can see like all the pressure will be having ATM unit. So ATM I have written one time. Now when you club the power of ATM, so you will be having gamma plus delta minus alpha in bracket alpha plus beta. Okay, it will be like this one. Okay, I'm writing. It will be like this one, ATM to the power gamma plus delta minus alpha plus beta, like this one. So whenever we are taking like difference of the coefficients of product and reactants, so they will be known as delta Ng. So that's why your unit becomes ATM to the power delta Ng. Delta Ng you have to see like coefficient you have to see for product and reactant. You take the summation, whatever you are getting, you have to put up in ATM to the power delta Ng. So that will be your Kp unit. Now, two we have discussed, Kc and Kp. Kc uses concentration as a proxy for active mass. Kp uses partial pressure as a proxy for active mass. Now, third one is Kx. Kx will be using mole fraction as a proxy for active mass. So just instead of partial pressure, I will be writing like mole fraction. So you can write mole fraction of C to the power gamma multiplied by mole fraction of D to the power delta divided by mole fraction of A to the power alpha into mole fraction of B to the power beta. So you can see I have written product of mole fraction of products in numerator raised to the power their coefficient, and in denominator I have written product of mole fraction of reactant raised to the power their coefficient. And if I talk about like unit, so since mole fraction you already know, it is like fraction of a component, fraction of number of mole of a component. So that will be like, suppose if I'm taking mole fraction of A, so it will be Na upon N total. So both N will be cancelled out and you will be having unitless. So mole fraction is unitless. So that's why Kx will be also unitless. So here in right side I have defined Xa is mole fraction of A, Xb mole fraction of B, Xe mole fraction of C, and Hd mole fraction of D. Okay. So I'm giving you 1 minute. Please write down this slide. Then I will be moving ahead. And if you have any doubt, you can ask me. Okay, written?
Yes.
Okay. So moving next. So in last class also I have told this one to you, that active mass is like, how much activity is showing to go for equilibrium. More the active it will be, like more easily equilibrium will be achieved. And if you are disturbing the equilibrium, it will be more sensitive towards it to restore the equilibrium. So we know that the gases are having very much high activity. That's why we are considering for gases only in our expression when we write for Kc, Kp, Kx for active mass. But when we write Kc, Kp, Kx, or the active mass expression for solid and liquid. If any if any component is present in solid or liquid in any chemical reaction, for that we take active mass to be 1. Okay, so active mass is taken as 1, then you are going to use concentration as a proxy for active mass. So if active mass is 1, so of course there is no need to use concentration. Means any concentration, partial pressure, mole fraction, whatever you are going to use, already active mass is taken 1. Okay, so this why I'm telling, because you can have misconception that when you are writing the expression for Kc, Kp, Kx, the place where the component of solid or liquid is coming, there I will be writing 1. So you may think the concentration is 1. No, concentration is not 1. Partial pressure is not 1. Active mass is 1. Okay, active mass is 1, and we are going to use concentration as a proxy for active mass. Already you have defined active mass to be 1. So there is no need to define further concentration or partial pressure for solid or liquid phase. Only you have to take gaseous phase, and for gaseous phase, if they are asking Kc, write concentration as a proxy. If they are asking Kp, write partial pressure as a proxy. Okay, only for gaseous phase. Solid and liquid, you can take 1. Okay, so there may be instance like all the phases of reactant product, there is no gaseous phase. There is only solid and liquid phase. So in that case, you can say like Kp cannot be defined because there is no gas phase present. So how you will be writing partial pressure of gas? So you cannot define it. So like this, you have to define Kp, Kc, or Kx. Okay. So now I will be giving you a bunch of questions. So first 2 I am discussing by myself. Then the 7 others are will be for you. Okay. So sometimes I will be lotting. Then you will be doing. Then we'll be discussing according to that one. Okay. So you can see here it is written Kp. Kp is defined only for gases. So first they have to see like if gases is not present in any of the components, so Kp cannot be defined because there is no point of partial pressure. Like in the first one, you can see. First one, you have see it is written NH3 aqueous, H2O liquid, NH4 aqueous, and OH minus aqueous. So since all the 4 state does not have any gas, the 2 reactant 2 product does not have any gaseous phase, so Kp cannot be defined. Partial pressure of gas you cannot define in liquid and aqueous phase. Now if you talk about Kc, so Kc what we are writing? Product of product concentration divided by product of reactant concentration raised to the power their coefficient. But for liquid, I told active mass is 1. So your H2O concentration will not be coming in expression because active mass of H2 is already 1. So in denominator, you will be only writing NH3 concentration because it is aqueous. It is not solid, it is not liquid. So for aqueous, we can write. For gaseous, we can write. Solid, liquid, already 1. And for numerator, you can see I have written concentration of NH4 plus and concentration of OH minus because they are in aqueous phase. So that for that purpose, Kc becomes like this one. Concentration of NH4 plus into concentration of OH minus since they are in aqueous phase. In denominator, H2 is liquid, so already taken 1, so no need to write concentration for that one. You write only concentration of NH3 aqueous. Now second example, the equation is like this one. 3O2 gas gives you 2O3 gas. So both are gaseous phase. There is no issue. Kp can be defined very easily. So your Kp will be like partial pressure of O3 because O3 is in product raised to the power 2. Okay, partial pressure of O3 is square because the coefficient is 2 here, divided by partial pressure of O2 raised to the power 3 or PO2 cube because the coefficient is 3. Only one reactant, one product is there. So product you do not have to do, you have to just write product and reactant raised to the power their coefficient. Now Kc for gases, Kc is defined, just you have to put concentration. So in numerator you will be writing concentration of O3 to the power 2. Okay, concentration of O2 to the power 2 because the coefficient is 2 here, divided by concentration of O2 to the power 3 because coefficient is 3 here. So in this way we have to define. Look, for gases is not present, Kp cannot be defined. For Kc, solid, liquid, do not you have to write Kc because active mass is taken 1. For other phases like gases and aqueous, you can include the concentration raised to the power their coefficient. So I'm giving 2 minutes, write this one. Then there will be like 7 questions that you have to do by yourself. Okay, so I will be giving some time, then we'll be discussing it. So first, please write this one. Okay, written.
Yes, sir.
One second, sir.
Okay, okay, right. Saket, you have done assignment. Hmm? La-
Sir, no, sir. When I tried to open it, it said I had to renew the thing in class two in learners.
So it has not opened for you. Soham, you have opened.
So the same thing for me also.
So it was not opening.
No, sir.
But I have renewed the course. Means it is problem for from your account end or from my link end. Do you know this one?
No, sir. So what is this? Sir, we to renew the course, and that's all that it says.
It is telling like this one to you. You have to renew the course.
Yes, sir.
Okay, fine. See, means whatever the links I am giving, I have increased the number of attempts for that one. Now I will be asking Santosh that why such message is coming to you. Okay. Then, so today also I will be uploading link and I will ask them to renew the course for you so you can attempt. So please try it tomorrow. Okay. Okay. So these are the list of questions. So I am giving you 10 minutes. I'm giving to you. After 10 minutes, we'll be start discussing. Okay, done everyone. Saket.
Yes.
Okay, so explain me one by one. First one, who will explain third one?
Sir, Kc is the concentration of CO2 raised by 3 into concentration of H2O raised by 4 by concentration of O2 raised by 5 into concentration of C3H8, and Kp is the partial pressure of CO2 raised by 3 into partial pressure of H2O raised by 4 by partial pressure of O2 raised by 5 into partial pressure of C3H8,
Okay,
because
very,
they're all gases.
okay, very good. Saket, you tell fourth one. Saket, can you hear me? Okay, so you tell fourth one.
So I got K C is 1, Kp is not defined.
Kc, what you told? Kc?
So 1.
1. How it will be 1? For solid
So
and liquid, I
there are
told. No?
no gases here.
See, for solid and liquid, you have to put 1. So what for aqueous you will be writing. Okay. In the last case, you can see no this example when I have taken this first one. The first one we are having aqueous, liquid, aqueous, and aqueous. But see, Kc I have defined. Liquid I have taken 1. Liquid and solid will be 1. But for aqueous, we can write concentration. Okay. So tell me fourth one. What will be the Kc?
So for aqueous solution, we can write the so it is concentration of Hg plus into concentration of I minus.
And in divide, AgI will not come because it is solid. So activity is taken solid for 1. Okay. For aqueous, we can write. No issue. And Kp will not be defined. Partial pressure we cannot define because there is no gas. But Kc we can write. Saket, can you hear me? Saket, you are not there? Okay, so listen, I have talked to Santosh sir, who is technical head. He told me that there will be one learnist email ID given to you that you can send me. I will forward to him. He will renew the course. Then you will be able to do the assignment. Okay. So in chat box, you can send me whatever your learnist email ID is. I will send to Santosh sir.
Yes.
Okay. Okay. Fifth one. Tell fifth one. So
Sir, Kc is 1 by CO2. Kp is not defined.
fifth one.
Yes, sir. Kc is 1 by CO2. Kp is not
Okay.
defined. Just Kc.
Okay. So yeah. So there are two solid and one gas. Gaseous phase is present. So Kp will be 1 upon CO2 and Kc what you have told? Not defined.
No, there's a Kc is 1 upon CO2. Kp is not defined.
No, Kp will be defined. No? Here one gas is present. No, the CO2 is
So
there.
I thought that Kp is not defined when like anything solid is present.
No. Any one solid not. If entire you are not having gas, any one gaseous phase is not present. I mean to say, like in the previous one, when I've taken this first one, so you can see none of the component is in gaseous phase. So that's why Kp was not defined because if gas is not there, how can you can define partial pressure? But if any one gas is there, so you can write PCO2. No? So your Kp will be defined here. Kp will be 1 upon partial pressure of CO2 and Kc will be 1 upon concentration of CO2.
Yes, sir.
Okay. Amitesh not came. It is 7:15. Okay, fine. Tell this sixth one.
Sir, Kc is Br2, the concentration of Br2 gas by the concentration of Br2 liquid. Kp is partial pressure of Br2 gas.
So Casey, what you told, concentration of Br2 divided by
gas by liquid.
liquid we are not taking, no? That only I told, no? Liquid and solid you take
But
activity
we
1.
took the aqueous solution before, for like Ag plus and I minus.
So they were aqueous. Aqueous is different from liquid, no? There are 4 phases, no? Solid, liquid, gas and aqueous. Solid and liquid I told you take 1. Gas and aqueous you can take. Liquid is different, aqueous is different.
Yes.
I think it is not clear to you. Why you are second answer you have given wrong? It is not clear. May I tell again how to do?
No, sir, I got it. I got confused between what was aqueous and what was liquid.
Aqueous is like dissolved in water, that we can consider because ions are having very much high activity. Okay. But you take neutral compound Br2 liquid. Liquid is not having much activity because it is not having ionic form also. Aqueous is also a kind of liquid, but since water is there and ions are there, so activity is higher. So for aqueous, it is allowed. Only for solid liquid, you take 1. And if entire you are having solid liquid, no gas is present, so Kp is not defined. Okay, so now tell 7th one.
Sir, Kc is the concentration of NH3 raised per 2 by the constant H2 raised per 3 into concentration of N2. Kp is the partial pressure of NH3 raised per 2 divided by the partial pressure of H2 raised per 3 into partial pressure of N2.
Oh, very good. So all the gases are there. So Kp you can define very easily. Partial pressure of, you have to take NH3H2 and N2. And with respect to concentration also for gas, you can define very easily. Now tell for 8th one.
Sir, Kc is the concentration of NH3 and Kp is the partial pressure of NH3.
Very good. So other two are solid. So solid activity mass is 1. So whether it is Kp, so pressure will not be written in place of solid. If it is Kc, then also concentration will not be written in place of solid because activity mass is 1. So only NH3 gas is there. So Kp will be partial pressure of NH3. Kc will be concentration of NH3. Saket, can you hear me? Are you attending class?
So it was not clear, sir.
Voice is not clear of mine or yours.
Sir, yours.
My voice is not clear. So to you also.
No, sir, it is clear for me.
So Saket, there is any issue with respect to connectivity from your end, not my end. Okay, tell Saket the last one, 9th one. Can you hear me?
Yes, sir. What did you say?
Tell this 9th one.
Yes, sir. Once again.
Kp and Kc you have to tell. Okay, so you tell.
Sir, Kc is 1 by concentration of O2 raised by 5 and Kp is 1 by partial pressure of O2 raised by 5.
Very good. So other two are solid P4 and P410, so they will not come in expression, neither in Kp, neither in Kc. So Kp, only partial pressure of O2 and the 5 will come because ratio to the power coefficient 1 over partial pressure of O2 to the power 5. The second one is Kc, so 1 over concentration of O2 raised to the power 5. Okay, so here I have written the solutions also. So whatever we discussed, it will be written here. So you can see aqueous, we have to define Kc. Okay, so this question I am giving to you. I am giving you 3 minutes, okay? Please solve this one. And Saket, you also solve. You are able to hear me? Saket?
So now I'm able to hear, sir.
You are not able to hear me?
So now I am.
Okay, so I am giving question. I am giving you 3-4 minutes. You attempt that one. And in chat, you can see like Soham has written Learnist email ID. You also write Learnist email ID. So I will tell the management to renew the course. Then you will be able to attempt the assignment. Okay?
Okay,
Just
sir.
listen. Okay. So I'm showing the question. Okay, done. Amitesh, you came now. Amitesh, can you hear me? Okay, a few minutes back. Okay, so I'm done this question.
Yes, sir.
Saket, you.
Sir, no, no, not yet.
What you're told. I'm not able to hear. Okay, so shall tell how you have done. Hmm? Tell Soham. What answer you are getting?
I lost connection.
Okay, tell now, tell.
Yes, sir. So this is concentration by time graph. Okay, so as you can see at the right hand side, the equation is at an equilibrium, and the concentration on the products, that is of B is 0.4 moles, and that of A is that is a reactants is 0.1 moles. So the Kc is basically the concentration of B square by concentration of A, which is 0.4 square by 0.1, which is 1.6.
So it is right. Only one correction that you told 0.4 mole. No, it will be 0.4 molar. We say molar.
Yes, sir.
Otherwise, you have told right. So the purpose of giving you this question was that one. Whatever the concentration is before equilibrium, so that is not of our concern. Whatever the law we have defined of active mass, and that I've told expression to write Kp, Kc, Kx, that has only to do with the concentration of equilibrium. Your K, Kp, Kc, Kx is only defined for equilibrium. It has nothing to do with before equilibrium. So in the graph, you can see when the equilibrium is attained, your product concentration is 0.4 because the product concentration will be increasing. And the reactant concentration, you can see it is 0.1 molar because it will be decreasing. This we have discussed, and they have to become constant. So product concentration is 0.4 molar, reactant concentration is 0.1 molar. And when we write Kc, we write product concentration raised to the power coefficient. So concentration of B square upon concentration of A. So B is 0.4. So 0.4 square upon 0.1. Okay, so you can easily find this one 0.4 square upon 0.1. That will be your answer. Okay, so next we are going to discuss like how we can derive a relationship between Kp and Kc. Okay, so Kp and Kc separately we have seen, but what is the interlinkage between Kp and Kc? Suppose Kc is given to you, so how you can write Kp? If Kp is given to you, how you can write Kc? So we have to see a relation between Kp and Kc. So for that purpose, you can see the equation is written like this one. Alpha A gas plus beta B gas gives you gamma C gas plus delta D gas. So for deriving what I will be writing, I will be first writing Kp. Okay, so Kp is how it will be written: partial pressure of C raised to the power gamma, partial pressure of D raised to the power delta, divided by partial pressure of A to the power alpha and partial pressure of B to the power beta. This will be your Kp expression. Now, since we want to develop relationship between Kp and Kc, there has to be some concentration terms in this Kp itself. Then only you can introduce Kc. So for that purpose, we will be using ideal gas equation, that is PV equal to nRT. And here we will be try to make some concentration terms. Okay, so that we can link between pressure and concentration terms. So PV is equal to nRT. So volume can come on right hand side. So N by V we can write P equal to N by V RT. And you know now N by V is what? Number of moles divided by volume. in liter. So that is what? Concentration. So your formula became P is equal to CRT. Now you got a relationship between concentration and pressure. This you can substitute. So for PA, you will be writing concentration of A into R into T. You know now ideal gas equation, you know all. Ideal gas equation, P is equal to nRT. This has been taught to you.
No, sir.
PV is equal to nRT, you do not know.
Sir, I know it. We haven't been taught in Centum.
In Centum, they have not taught in Accelerator
No, sir.
module 1. Okay, so a brief I am telling you. The ideal gas equation, this is known as ideal gas equation, PV is equal to nRT. Because like in class 8 and 9 years, you are studying some of the properties of gases, that the particles are sphere in shape, they are identical in shape, and their volume is negligible. They are very far apart, increasing temperature, kinetic energy increase. Such type of properties you study in 8, 9 related to gases. So based on that one, and there are different laws, like for example, Boyle's law. Do you know Boyle's law? Hmm? Boyle's law, I think in school also it is taught.
Sir, P1, PV1 is equal to P2V2.
Yeah, PV is equal to constant. Okay, your P, you can say P is directly P is inversely proportional to volume. Then we have Charles' law, Gay-Lussac's law. Okay, Charles' law, volume directly proportional to temperature. Am I correct? And Gay-Lussac's law, pressure directly proportional to temperature. And then we have one more law, Avogadro law, volume directly proportional to number of moles. So this four equation of these four scientists, Boyle's law, Charles' law, Gay-Lussac's law, Avogadro law, if I combine, so I get one equation, PV is equal to nRT. Here you can see Boyle's law is there, P is inversely proportional to volume. Avogadro law is there, volume is directly proportional to N. Pressure is also proportional to temperature, volume is also proportional to temperature. But there is one more term, R. So R is constant value for ideal gas equation. R value is 8.314 joule per Kelvin per mole. Okay, so I'm writing here. R is 8.314 joule per Kelvin per mole. Okay, when you are writing in joule, and suppose you have to write in terms of ATM, so that value becomes 0.0821 in terms of ATM. Okay, so this you do not have to remember. Right now it is not required, but since you do not know PV equal to nRT, that's why I'm giving you this information. So R is one constant value in joule, 8.314. When we write in ATM, it is 0.0821. Okay, so now this is PV is equal to nRT. So pressure, C for pressure, V for volume, R I told you, N is number of moles, T is temperature, and temperature here it should be Kelvin. Okay, temperature here we put in always Kelvin. We never put in degree Celsius. So applying this PV is equal to nRT. When you put volume below number of moles, you get P equal to CRT, because concentration is what? Number of moles per unit volume, or molarity you can say. So now I got a relation between partial pressure and concentration. So PA can be written as CART. CA I can write like this one is square bracket concentration of A. PB can be written as CBRT. CB can be written as concentration of B. PC I can write C concentration of C RT, concentration of CRT. And partial pressure of D I can write concentration of DRT. Okay. So now I have to substitute in place of PA, PB, PC, PD this concentration term into RT. Okay, so I'm giving you 1 minute. Please write this one. Then we'll be deriving ahead the relation between KP and KC. Okay, written this. Amitesh Saket. Hmm?
So one second.
Right, right. Where is Harith? Harith not came. He's he's coming alternate. Okay, so I'm moving ahead. So when I will be substituting in place of PABB, PAPB, PC, PD, okay, so it will be looking like this one. So in place of PC, I have written concentration of C into RT raised to the power gamma. In place of PD, I have written concentration of D into RT raised to the power delta. And in denominator, PA, I have written concentration of A into RT raised to the power alpha. Concentration of means PB, in place of PB, I can write concentration of B, RT raised to the power beta. Now what I can do, since you can see RT is coming common in all the four, however the power will be different. So concentration I can separate, RT I can separate. So if I separate concentration on left hand side, so I will be getting C to the power gamma into D to the power delta divided by A to the power alpha into B to the power beta. And on right hand side I am getting RT to the power gamma into R to the power delta. Likewise in denominator R to the power alpha, R to the power beta. Now this you can see I have written inside box. This is nothing but Kc. Kc is defined like this only. If the same equation is given to you, and if you are defining like Kc, so that will be concentration of C to the power gamma, concentration of B power delta, concentration of A to the power alpha, concentration of B to the power beta. And this RT can be now again simplified in terms, means you write one time RT only and you express in the power. In the power it will be gamma plus delta minus alpha plus beta. And this is nothing but delta Ng. So your expression became Kp is equal to Kc into R to the power delta Ng. Delta Ng, once again I am defining delta Ng. See, delta Ng is what? You do the summation of coefficients of product. Like for example, in this particular reaction, we are having alpha A plus beta B, gamma C plus delta D. So the coefficients of product side is gamma and delta. You do summation of gamma plus delta. You do summation of coefficients of rated side, alpha plus beta. Then you take the summation. So basically, delta Ng is difference in number of moles of gaseous products. Okay. So that's why here gamma plus delta minus alpha plus beta became delta Ng. So this is the expression you have to remember. Kp is equal to Kc into R to the power delta Ng. So I'm giving you 2 minutes to write this one. Then we can move ahead. And if you have any doubt, you can ask me. Okay, written. Sakir.
So the last thing.
Right.
Done.
Okay. So now we have to see like in which case Kp will be greater than Kc, in which case Kp will be less than Kc, or in which case it will be equal. So it will be dependent on delta Ng value. If your delta Ng is greater than 1, I mean the coefficients on the product side are higher, summation. So you will be writing Kp is equal to Kc into RT to the power delta Ng. Delta Ng is greater than 1. So of course your Kp will be coming higher than Kc because RT will be having something value and you are raising it to the power delta Ng. Delta is greater than 1. So Kp will be greater than Kc. Kc is case 2 taken like this one. So delta Ng is less than 1. Okay, so delta Ng is less than 1. So when you write Kp equal to Kc RT to the power delta Ng, when your power is less than 1, so that will be like decreasing the value to which it is multiplied. So Kc into RT to the power delta Ng is less than 1. So after multiplication RT to the power delta Ng, your Kp will be lesser than Kc. So this is case 2. Now there can be situation when delta Ng is 0. Your product summation is equal to patent summation. So in that case, what will be happening? Kp equal to Kc, RT to the power 0, and something to power 0 is always 1. So Kp will be equal to Kc. Now fourth case, when you are having temperature equal to 1 by R. R value I have already told you, it can be 8.314 or it can be 0.0821. So when your temperature is having 1 upon 8.314 Kelvin, like that one. So in place of temperature, you can write 1 upon R. So Kp is equal to Kc R into 1 by R. So in place of temperature, I have written 1 by R to the power delta Ng. So this R will cancel out and you will be getting Kp into Kc into 1 to the power delta Ng. Now 1 to the power delta Ng is always 1. 1 to the power something will be 1 only. So here delta Ng can be anything, no issue. Temperature is 1 by R. So you will be getting Kp equal to Kc. In case 3, temperature can be anything. Delta Ng is 0, then Kp equal to Kc. And when delta Ng is greater than 1, Kp will be greater than Kc. When delta Ng is less than 1, Kp is less than Kc. So I'm giving you 2 minutes, you can write this one. And if you have any doubt, please ask me. Okay, written. Saket.
Yes, sir.
Okay. Now next we are going to define the relationship between Kp and Kx. Okay, so like we have seen Kp and Kc, so Kp and Kx. Now equation we can write alpha A plus beta B gives you gamma C plus delta D. So Kp can be written like this one, Pc to the power gamma into Pd to the power delta divided by Pa to the power alpha into Pb to the power beta. Because AB are reactants, so they came in denominator, CD are products, so they came in numerator, and they are raised to respective coefficients. Now, in left side, you can see the relationship between pressure and total pressure and partial pressure is written. Do you know this relation? That partial pressure is mole fraction times total pressure. Hmm? Do you know this?
No, sir.
Okay, so let me derive this one. Suppose you are having any container where there are A, B, and C gases. Okay. So I told that A, B, C component when they are non-reactive. First one, when they are non-reactive, and second one is they share same volume as that of container. Okay. So if I want to write like P total pressure of all the gases, that will be equal to PA plus PB plus PC. Partial pressure of A plus partial pressure of B plus partial pressure of C. Partial pressure is the pressure of individual gases. Now, since we know that PV is equal to nRT, right now only I have told ideal gas equation. So PA can be written as nRT by V, and A will be there. So PB can be written as NBRT by V, and PC can be written as NCRT by V. V will be common for all ABC because they are sharing the volume of container, and your V is volume of container. V is volume of container. Okay. Now I can substitute in place of PAB PC, and P total can be written as N total RT by V. So in place of PA, I will be writing NA RT by V. In place of PB, I will be writing NB RT by V. In place of PC, I will be writing NC RT by V. Now RT by V can be taken common. Here N total RT by V, and here I can write RT by V common, NA plus NB plus NC. So RT by V can cancel out, and you are getting N total Na plus Nb plus Nc. So this we got one relation, that your number of moles of the total container will be number of moles of A plus number of moles of B plus number of moles of C. So this you already know. So this is logical also. Like when you are doing summation of pressure for total pressure, you have to do summation of number of moles for total number of moles. Now next, what I'm going to do, I'm going to take the ratio of PA upon P total. Okay, so I'm going to write PA upon P total. So in place of PA, I can write NART by V using PV equal to nRT. In place of P total, I can write N total RT by V. Now here RT by V will be cancelled out. You are getting NA upon N total. So can you tell me what is this Na upon N total? Is there any name for this one?
So the mole fraction of A.
Yeah, very good. So here you got what? Pa upon P total is equal to mole fraction of A. So XA is mole fraction of A. So likewise, I can also write PB upon P total mole fraction of B. This can be rearranged like this one. Pa is mole fraction times P total, or it can be also written as PB is mole fraction times P total. So this is the law of Dalton's law of partial pressure, that your partial pressure is mole fraction times of total pressure. That's it. Understood? Any doubt in this? From where we got this expression? L Saket Amitesh Soham. Now,
Yes, understood.
okay, fine. So now we are coming back to this one. So we got now how to relate pressure with mole fraction. P partial pressure of A is mole fraction A times total pressure. Partial fraction of B is mole fraction times total pressure. Partial pressure of C is mole fraction times total pressure. Partial pressure of D is mole fraction of D times total pressure. So here we got relation between pressure and mole fraction. So quickly we can substitute partial pressure in terms of mole fraction so that we can get mole fraction term in the expression. So you can see in place of partial pressure it is written mole fraction times total pressure. Now here, like in the previous one, we have done RT one side and concentration terms one side so that we can introduce Kc. So here also you can do mole fraction, although mole fraction one side and pressure on one side. So you can see you can write like this one: mole fraction of C raised to the power gamma, mole fraction of D raised to the power delta divided by mole fraction of A raised to the power alpha and mole fraction of B raised to the power beta multiplied by P. And for P you have to write gamma plus delta minus alpha plus beta, because gamma delta come in numerator, there's our product side, and alpha plus beta is reactant side, they are coming denominator. And this alpha gamma plus delta minus alpha plus beta is nothing but that is delta Ng. Okay, so that will be delta Ng. So in place of X, this written, you can write mole fraction to the power delta Ng into P. Okay, first you write this one. I'm giving you 2 minutes. Then we'll be discussing the next slide, the relation between Kp and Kx. Okay, written. Amitesh, so I'm written. Okay. So okay. So here also we have to see like different cases. In which case Kp will be greater than Kx, in which case Kp will be less than Kx, and in which case Kp will be equal to Kx. So first case you can see, since here we are involved with like P to the power delta Ng, and your pressure value can be less than 1 atm also, it can be greater than 1 atm also. So two cases I have taken here, when your pressure is greater than 1 atm and when pressure is less than 1 atm. Because when you are having like greater than one quantity and you are raising to the power, it increases. But if you are having some fraction less than 1 and then you are raising to some power, it will be decreasing. So that we have to see here. So first case taken, delta Ng is greater than 0. So Kp is equal to Kx into P to the power delta Ng. Pressure is already greater than 1 and delta Ng is also greater than 0. So positive power will be there and your value is also greater than 1. So something greater than 1 to the positive power will increase the value. So that's why Kp is greater than Kx. Second taken, delta Ng is less than 0. So when delta Ng is less than 0 and your pressure is greater than 1, so what will happen, like you are raising to negative power. So when you are raising to negative power, it will come in denominator. When you are raising to negative power, it will come in denominator. And that will be like less than 1. So that will be decreasing the value when you are multiplying with Kx. So that's why Kp is equal to Kx into P to the power delta Ng. Delta Ng is less than 1 negative. Pressure is greater than 1. Since the power is negative, that will be like coming in denominator and that will decrease the value of Kx on multiplication. But that's why Kp is less than Kx. Third case, you are having delta Ng is 0. So P to the power 0 will be 1. So that's why you are having Kp is equal to Kx. Now second case taken when pressure is less than 1 atm. So first case taken when your delta Ng is greater than 0. So you can think like when pressure is less than 1 atm, so it can be like any value like 0.5. So when you are raising the power to 0.5, suppose delta Ng I take 0, positive value, sorry, 2 I take, delta Ng is 2, it is positive value. And pressure I have assumed 0.5, less than 1, 0.5. So 0.5 to the power 2, that will become how much? 0.25. Means when you are having less than 1 value and you are raising to positive power, the value decreases. Do you know this thing? In math, you have studied this one. When you are having 0 to 1 value and you are raising to positive power, the value decreases.
Yes, sir.
Okay, so the same thing is happening here. So since pressure is less than 1 atm, so when you will multiply with Kx, your value will decrease. Your Kp is less than Kx. One minute. Some important work here. Okay, fine. So second case we have taken when we are having negative power. So pressure is less than 1 atm, so pressure I can assume 0.5, less than 1. And delta Ng is negative. So delta Ng I can assume -2. So 0.5 to the power -2. So that will become 1 upon 0.5 square. So 1 upon 0.5 square, 0.5 square will increase. Sorry, 0.5 square will decrease. So your denominator will decrease. So since here you are having less than 1 value also and negative power also, so you both decreasing factor are actually increasing the value of Kx. Okay, so once again I am telling this one is somewhat complex. So second one, when your pressure is less than 1 atm and you're having negative power. So since it is negative power, it will go in denominator, and your value is less than 1. So your denominator value will decrease because you are having a less than 1. So when you are doing power to it, it get decreased. So your denominator is decreasing, so numerator will be increasing. I mean to say fraction will be increasing. That's why Kp is coming greater than Kx. And the third case, delta Ng is 0, so you get Kp to the Kx. So that is the same like the previous one. Okay. So please write this one. I'm giving you 2 minutes, and you have any doubt, you please ask me. Any doubt in this? Amitesh, you understood? Hmm? Please reply in chat if you are not able to speak. Okay, fine, you have replied. And Saket is not stable. He is sometimes going, sometimes coming. Okay, written everyone. Amitesh written. Home.
Yes, sir.
Okay, fine. Okay, so one question is displayed. So I'm giving you 3-4 minutes. Please solve it. Then we'll be discussing it. Okay, done this question. Mitesh? Okay, do. I'm giving you 1 more minute. Okay, done now. Mitesh, can you explain how you have done? Oh, your mic is not working. Saket, you can explain? Hmm? Okay, so you explain how you have done.
So the first one, so NG is -2, so KP is less than KC. The second one, NG is 0, so KP is equal to KC. Third one, NG is -1, so KP is again less than KC. And the fourth one, NG is 1, so KP is more than KC.
Okay. So please remember delta NG when we are finding out, so only do the summation for gaseous phase coefficients. Never touch the solid or liquid one. So here already I have given all the gases. But suppose if any one of the component is in solid or liquid, so that coefficient we do not do addition or subtraction. Okay, so you are right. Answer will be D. You can see here I have written like Soham told. The formula is Kp equal to Kc RT to the power delta Ng. This you have to apply, and different cases I have told you. So here they are asking for Kp greater than Kc. So your RT value is already greater than 1 only. Okay, because temperature you cannot take less than 1. That is meaningless. So delta Ng should be less than 0. So negative power will decrease the value by multiplying it. No, sorry, they are asking for Kp greater than Kc. Okay, they are asking Kp greater than Kc. So delta Ng should be greater than 0. Then only your Kp will be higher than Kc. So first option, delta Ng, you can see all the phases are gases. So 2 minus 4, that is give you -2. So when the power will be negative, so it will decrease the value, but we want increase. B option, all the phases are gases. So 2 minus reactant summation, that is also 2, 1 plus 1. So 2 minus 2 is 0. So Kp will be equal to Kc. In C option, you can see it is 2SO2 plus O2 gas gives you 2SO3 gas. All the phases are gases. So difference will be 2 minus 3. That is minus 1. So again, your Kp will be decreased. It will be less than Kc. But in D option, since both are gases, you are having delta Ng 1. So this will give you greater value of Kp. Kp will be greater than Kc. Now, when I was discussing Kp and Kx, so in one more case, Kp can be equal to Kx, like one was delta Ng is 0. Another one is like you take pressure 1 atm. Okay. So when you take pressure 1 atm, so 1 to the power anything will be 1 only. So Kp will be equal to Kx, irrespective of value of delta Ng. So similar to like the previous one, where temperature I have taken 1 by R, here pressure I have taken 1. Okay, so this can be one of the case 3. Okay, I'm giving you 1 minute, you can write this one, then we can discuss next part. Okay, written. Okay, so Amitesh, you were not present. So in chat box, please write your learnist email ID. So I will tell the management to renew it. Then only you will be able to attend the you can attend the assignment. Okay, so you were not present when I have told this one. So Soham has written email ID. Saket has also not written. Saket, please write. Saket and Amitesh, please.
Sir, I sent it. It's not come for issue.
You have written in chat box. It is not
Sir,
showing.
I sent it 3 times.
So why it is not showing here? Only Soham it is showing. Send once again. And Amitesh, you also. No, please don't send in WhatsApp group because in group there are many other people. No? So it not be looking nice. You can send here or you can send me personal DM. Okay, but that you have to do like you have to search my contact number and all that. So it's better you can write here. Okay, fine. So yeah, let this one done. Okay, so these two questions are also there. I'm giving you 5-6 minutes. Please attempt it, and after this we can wrap up the class. In the meantime, you please write your email ID, Lanish email ID in chat box. Okay. Okay, so the questions we'll be discussing in next class. If you have attempted, then it is good. If you're not attempted, you can try in the meantime in the whole week. Okay. And Saket, you have not sent your email ID.
Sir, I sent it.
It is not reflecting here.
I sent it again 3 more times. It's not come.
Okay, can you tell? You tell manually. I am writing here. Tell what is your email ID.
So UMAIL.
M for monkey.
Yes.
UMAIL
RAJI
RAJI
at
at
Gmail gmail.com. Yes, sir.
Okay, I'm writing here. Please correct me that if it is right or wrong. UMAIL RAGI @gmail.com. Okay, so I'm writing in mail. Please confirm me it is right.
Yes, sir.
Okay, fine. So we are wrapping up. I will upload the assignment and it will be renewed. So please attempt the assignment. Next time I will be talking to you. Thank you, everyone. Next time we'll be discussing from here questions.
Okay, thank you.
Thanks.
Okay, okay.